Hey guys, and welcome to another video all about how to use systems of equations to help model real-world situations. So in this example, we're talking about the Super Bowl, we're talking about pizza. So when the Super Bowl comes around, pizza places get ready to sell a lot of pizza and make some serious dough. Yes, great pun, I know, thank you. But let's talk about a specific place, Sal's Pizza. And they have a goal of how many pizzas they'd like to sell, and how much they would like to make in total, but they don't yet know exactly how much they should charge for a small pizza and a large pizza to reach their goals. Okay, so here are the goals they've set up. They know that large pizzas should cost exactly $4 more than small pizzas. And if, like last year, they were to sell 70 small pizzas and 100 large pizzas, they want to make sure that their income is exactly $1,590. That's going to help pay for supplies, pay the workers, and offset all the other costs associated with making and delivering pizzas. So the question is this enough information to determine exactly how much they should charge for each pizza? But we're going to get there step by step. So first, let's start with the fact that large pizzas should cost exactly $4 more than small pizzas. So my question is, how much could the two possibly cost? I'm going to make a little table of values here, small and large, and let's come up with some possibilities for how much a small pizza and a large pizza should cost. I mean, at this point, we could almost come up with some random sorts of numbers. So if a small pizza cost $5, I think a large pizza would cost $9. If a small pizza cost $6, I think a large pizza would cost $10. If a small pizza cost $7, a large pizza would cost $11. Heck, if a small pizza cost $2, that'd be quite a cheap pizza. I mean, sign me up. A large pizza would cost $4 more. It would cost $6. And so it seems like there's a whole lot of possibilities for how much a small and large pizza would cost, with only the information being that the large pizza has to cost exactly $4 more than the small. So this is not enough information to determine exactly how much they should charge for each pizza. But what we're going to do is we're going to come up with an equation to describe all the different combinations for small and large pizza prices, given the fact that the large pizzas must cost $4 more than the small pizzas. And in general, we're going to have to define some variables. And as a general rule of thumb for me, I always define my variables as, well, what is it that we're looking for? What is it that we don't know that we want to know? In this case, we'd like to know how much each pizza is going to cost. That's the unknown information that we're going to want to find, and so that's where we're going to define our variables to be: the price of the small pizza and the price of the large pizza. And we're going to create one equation now, and if we can create a total of two equations, so one more later, then we'll have enough to solve a system of equations and figure out exactly what the price of the small pizza should be and the large pizza. So I'm going to use the variables A and B, just totally random. And we're going to have A, that's going to represent the price of a small pizza. And the variable B is going to represent the price of a large pizza. All right, so here we go. My claim is that the price of a large pizza, B, is always going to be $4 more than the price of a small pizza. So I'd say A plus 4. And so we've come up with one equation which describes the prices of the small and large pizzas and their relationship. Woohoo! Okay, we did it. Yay! All right, but now let's see if we can create another equation. So moving on. Given the fact that 70 small pizzas were sold and 100 large pizzas were sold, my question is, how much would be brought in? What would the income be if small pizzas were $10 and large pizzas were $14? Okay, and note I kept that relationship the same, that the large pizza was $4 more than the small pizza. Well, I think the total income would be 70 small pizzas times however much it is for a small pizza, right? We said if a small pizza were $10, so 10. And how many large pizzas? 100 large pizzas. I think that's the kind of number we were talking about before. And if they were 14, all right. Well, that would bring in a grand total of how much money? Well, from these small pizzas, 70 small pizzas times $10 a pizza would be $700. And 100 large pizzas at $14 a pizza would be $1,400 for a grand total of $2,100, $2,100. All right, good to know. I mean, that's cool. Good to know. I'm going to kind of toss that in the corner here. Okay. Now, I mean, what if small pizzas were $2? When we talked about $2 before, what if they were $2 and the large pizzas were $6? How much would it be? So, well, I think it'd be the exact same calculation, but instead of $10, I think it would be $2 for a small pizza. Instead of $14 for a large pizza, it would be $6 for a large pizza. Right? We're keeping the relationship between them the same. The large pizza is $4 more. Well, then we have $140 worth of small pizzas sold and $600 worth of large pizzas sold for a grand total of $740. So, with those same numbers of pizzas, 70 small pizzas, 100 large pizzas, if these were the prices, we'd have only $740. So neither of those, we didn't get lucky and randomly find the combination that we're looking for, because of course the total income we're trying to get is $1,590. But we do have some variables to represent the cost of a small pizza and the cost of a large pizza. And if we were to use variables in this case, we could come up with an expression for how much income we'd get if we were to sell, instead of using X and Y, I'm going to use the variables that we came up with, which were A and B. So if a small pizza cost $A and a large pizza cost B dollars, so just for consistency's sake, $A and B dollars. Remember, we talked about this before. A equals the price of a small pizza, B equals the price of a large pizza. Might as well copy paste that down here so we've got it easily accessible. And so my question is B. Awesome. Well, I think that the expression we're going to come up with is exactly the same as the ones we've been doing so far. So, well, if you sold 70 small pizzas and small pizzas cost $A, and you sold 100 large pizzas and large pizzas cost B dollars, well then the total income you get from that sale of pizzas, 70 small ones and 100 large ones, would be 70A plus 100B. 70 times A and 100 times B. And what's interesting, kind of making our move to the next prompt here, is that we know exactly how much we collected. We collected a total of $1,590. So it must be the case that 70 small pizzas times the price of a small pizza plus 100 large pizzas times the price of a large pizza, that has to sum up to $1,590. Oh, so this is all the different combinations of how much the small and large pizzas could cost, and have that be the total amount collected. And now we have a second equation involving these two unknown variables, A and B. Here's our first one. And now I claim we definitely have enough information to solve for both A and B. I mean, this is a system of equations, two variables. We're ready to rock. Let's do it. And I think definitely the best course of action is going to be to use the substitution method, because I think we've got one variable nicely solved for right here. Right? B is equal to A plus 4. So let's take this A plus 4 and whoop, toss it right in there. And let's see what ends up happening. We end up with a new equation. 70 times the price of a small pizza plus 100 times, well, $4 more than that, equals $1,590. And note to self, some people, instead of doing two variables, they just do one variable and they say, well, A is the price of a small pizza and A plus 4 is the price of a large pizza. I like to take my time and not get ahead of myself, so I use two variables and then use a substitution method. Okay, moving on. So let's do a little distribution. If we distribute that 100 to both of those terms in there, we get 100A plus 400, yowza, equals 1,590. Subtracting 400 from both sides of the equation yields us the new equation. Well, let's see, 170 times the price of a small pizza should be equal to, don't forget that, 0, should be equal to 1190. And if we were to divide both sides by 170, we find that A, the price of a small pizza, should be exactly $7. Hot damn! And if the price of a small pizza is $7 and a large pizza is $4 more, the price of a large pizza should be $11. So we think we found exactly how much a small and large pizza should cost. Let's just make sure by going ahead and substituting these values into the other equation. If small pizzas were $7, 70 times 7 is $490, and if large pizzas were 11, 100 times 11 is 1,100 plus 490 is 1,590. Amazing, it both checks out. So we have found that yes, indeed, the price of a small pizza should be $7, the price of a large pizza should be $11. And that's the general strategy here. We're defining our variables originally to be that which we don't know, that which we'd like to find. We are creating two equations involving these two variables, and then once we have two equations, boom, we can solve that system and we can find out the value of each.